Hi everyone, so I'm going to continue with a comparison between alkanes and alkenes. So both alkanes and alkenes, they are hydrocarbons, meaning that they contain carbon and hydrogen only in the molecules. They are both flammable, and when they burn completely, they produce carbon dioxide and water. However, alkanes have greater tendencies towards complete combustion, while alkenes have greater tendencies towards incomplete combustion because of the higher percentage of carbon in the molecule. Therefore, it's going to burn, it has greater tendency of burning incompletely or burning with a sootier flame as compared to the corresponding alkane. Alkanes are generally unreactive because of the strong CC and CH bonds, and because the bonds are non-polar. Alkenes, they are very reactive, especially at the double bond region. Alkanes will tend to undergo substitution reaction with halogens in the presence of UV light, while alkenes will undergo addition reaction with halogens, and it does not require UV light. With aqueous bromine, that is bromine water, or you could also use bromine in CCl4 solvent. With alkanes, there's not going to be any reaction if it occurs in the dark, but with alkenes, you're going to have decolorization from reddish brown to colorless. Combustion, so alkanes I've already mentioned produce a less smoky flame, but alkenes produce a smokier flame. So this mentions the use of ethene. So ethene is a gas that is produced when fruits ripen, and it causes other fruits to ripen as well. So this is why sometimes if you have unripe bananas, if you put the unripe bananas with a bunch of other ripe ones, it's going to ripen more easily. And if you want to slow down the ripening process, you have to prevent the buildup of ethane. So that's why they introduce carbon dioxide in the container containing the fruits to slow down the ripening process. The next reaction of alkenes is polymerization, and specifically addition polymerization. So addition polymerization is just basically you have the same unit that keeps on adding to each other. And alkenes are used to make plastics by an addition polymerization reaction. So under high pressure, alkenes add themselves to form addition polymers, and addition polymers occurs when unsaturated monomers join together to form one large big molecule as the single product. So if you have any number of alkene molecules, N is any number, and usually these numbers go beyond 100,000. It could be any number, any big number. So when these molecules come together under high pressure, they will add to each other to form a polymer. So a monomer is the smallest unit that is going to make the polymer. Poly means many, and the polymer is made from the monomer units. These are called continuation brackets, and these continuation brackets are important. So at the end of the polymer, you need to draw the continuation brackets where you have the bond crossing the bracket. This means that the the molecule keeps on going. And any alkene will undergo addition polymerization to form the corresponding polyalkene. So ethene will form polyethene, butene will form polybutene, pentane will form polypentane, etc. So let's take, for example, the monomer ethene. So ethene looks like this. Whenever you're doing addition polymerization, it's very important that you try to draw the molecule in this format. In the format where you have C double bond C, and then whatever else is bonded to the carbon will be on top and on bottom. So if you have a molecule like this, if you're given a molecule like this here, what you will have to do is just change the way that you draw it so that you have only C double bond C, and then everything else fits on top and bottom. So this first carbon here has H and H, and this second carbon here has H and CH3. So you're going to draw it in this way so that you can easily have the monomer and you can easily draw the polymer. So ethene is here. So polyethene is just going to be ethene, but without the double bond. So you'll break the double bond is going to open up on both sides as such. So it's the same thing without the double bond, and this keeps on going. So that's a second monomer being added. I can have a third monomer being added, and then I'm going to have the continuation brackets, okay, with the value of n showing that there is a large number of monomers that have added in the polymer. So this is an example. Or you can simply draw this here, and this here shows the repeat unit. The repeat unit is the part that's going to repeat itself in the polymer. As you can see here, C, 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 H, 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 H here. So C, C, H, 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 H. So this part repeats itself. So this is called the repeat unit. And the repeat unit is going to be the monomer. And you have to be careful that you draw the monomer in such a way that that you have two carbons side by side and the double bond in the middle, so that you can easily draw the repeat unit and you can easily draw the polyalkene. So let's try to draw another one, chloroethene. So chloroethene means that you have one chlorine in an ethene molecule. But you see here, I've drawn it in this way, but it's not in the format like this. So what I'm going to do, I'm just going to redraw it so that I have this H and the Cl on top and on the bottom. So now I have my monomer. From the monomer, I can draw the repeat unit. So it's just the same thing as the monomer, but I'm going to have the continuation brackets instead of the double bond. So no double bond in the repeat unit here. And from this I can draw the polymer. So it's just the repeat unit one after the other. And then you have the continuation brackets and the small number n. Do not forget to write the small number n. If you do not do so, it's wrong. You can also draw it in terms of structural formula, where chloroethene is CH2 CHCl. That would be the monomer. And then the polymer would be CH2, and then here the continuation brackets CHCl with the continuation brackets like that. That would be the repeat unit. And here, the polymer here. So this is chloroethene. So the polymer is polychloroethene. And previously, ethene was called vinyl. So chloroethene was actually vinyl chloride. This is the old name. So this is vinyl chloride. Therefore, the polymer is polyvinyl chloride. And this is what we know as PVC. So that's the PVC plastic. This is how it looks like. The next example is propene. So what I'm going to do, I'm going to draw propene. 1, 2, 3. Double bond. I'm just drawing it as I would normally. Once you draw the molecule, once you get the molecule, then you can change its orientation so that you have it in this format. So that's the first carbon that I have here. And this one has H and H. And this carbon, the second carbon here, has H, and this is a CH3 group. So H and CH3. It doesn't matter if you put the CH3 on top or the H at the bottom. It really doesn't matter. The important part is that you respect the group attached to each carbon. So here you have the monomer. Once you get the monomer, you can get the repeat unit, which is the same thing as the monomer. Just remove the double bond, put single bond, and then you have the continuation brackets. So from this now you can get the polymer. So the polymer is just the repeat unit brought together. So you can choose to draw 3 to 4 repeat units. I'm going to draw only 3 repeat units. So this is the polymer and this is polypropene. Be careful, even if you do not have any double bonds in there, even if it is not an unsaturated molecule, it's still propene, polypropene, because this comes from the propene monomer. So the name of the polymer is simply the polyalkene. So whatever the name of the monomer, you just add poly in front. Then you have one last example, tetrafluoroethene. Try to do this one on your own, pause the video, and then you check your answer. Now tetrafluoroethene, tetra means 4, fluoro means fluorine, so 4 fluorine in the ethene molecule. That's the monomer. Here you have the repeat unit, and here you have the polymer, polytetrafluoroethene with 3 repeat units. Do not forget to put the continuation brackets and the end. Let's have a little recap of the alkenes. So they undergo combustion reaction, complete combustion, incomplete combustion. You have to be able to write both equations for alkenes. It's going to give a sootier flame as compared to its corresponding alkanes. When they burn, they undergo addition reactions. You can have 5 different types of addition reactions. So these are all the addition reactions. The hydrogenation, where you get an alkane. When you react with bromine, you get dibromoalkane. These are the conditions. These are the observations. And this is the test for an unsaturated molecule. Addition of chlorine, you get dichloroalkane. You see decolorization, and the characteristic smell of chlorine or bleach goes away. Addition of steam to produce alcohol. These are the conditions. And addition of hydrogen halide, where you get the halogenoalkane. So these are the 5 addition reactions that you should know for alkenes. And also the last reaction is addition polymerization, where you should be able to draw the monomer in this form, the repeat unit, and the polymer. So that we have just done today. So this is an overview of alkenes.